Hello, my name is Mike Driscoll, and today I'm going to talk to you about Python decorators. Let's get started. This is some of the stuff that I'll be talking about in this tutorial. How functions work, function introspection, a little bit about closures, how to create a decorator, stacking decorators, decorators that accept arguments, some practical decorators, decorators from the standard library, and I forgot to mention, but I'll also cover class decorators too. So let's go ahead and get started learning about all these wonderful things that have to do with decorators. Alright, so what is a decorator? A decorator will take a function that they're decorating and extend its behavior while not actually modifying what the function itself does. I'll probably define this again later on, because first we're going to talk about the humble function. What is a function anyway? So a function consists of the define statement, def, the name of the function, and then any arguments that it takes. And you can create functions that don't accept anything. In this case, the function accepts one argument. So it accepts like 5. Now, of course, being Python can multiply strings too, so you could pass in a string as well. Because Python doesn't really pay attention to the types, and strings can be multiplied. Let's talk about function parameters though. So you have normal parameters, keyword parameters, variable arguments, variable keyword arguments, and in later versions of Python you can also specify that it only accepts certain types of positional arguments or named arguments too. I'm not going to cover that right now. Alright, so here's like a normal example. We have parameters x and y, it prints x and y. You can run the code, it works the way you would expect it to. Now we have normal plus keyword arguments. So the normal ones are x and y, but z is a keyword argument because we are also known as a default argument because we're setting it to 2. If you run it the first way, with 7 and 1, you can see that those are the args. And if you set z as well, then we have a keyword argument. So the first one through, the keyword argument is 2 because that's the default. And then the second time you run it, the z is now foo. Alright. What if we want to have an arbitrary number of arguments? We could add as many as we want. You can do that with star args. So in this case, we can have as many arguments as we want. I can keep adding them, and it'll keep accepting them because I have the star args there. We could do star args and then keyword argument. So if I rerun this code, you can see that the keyword argument is still 10 and then foo, but the arbitrary arguments can be any number. So I could continue to add numbers here, and it'll still happily work that way. What if I want an arbitrary number of args and keyword arguments? To do that, you do star args and star keywords. And then, just for fun, I'm going to show you how to pass those in. So we could do, when you do this, you want to pass in, x equals this, y equals that, or you could do keyword arguments as a dictionary. So I show it both ways. The first example, we do star args, which will unpack the list, and star keyword arguments, which will unpack the dictionary and pass them in. In the second example, I'm only unpacking args, but I'm doing foo and bar as the keyword arguments, which you can see gets turned into a dictionary anyway for keyword arguments. So that's nice. So everything in Python is an object. You might be wondering, why is this important for decorators? I'm getting there. Just wait for a little bit, and you'll find out why all this matters. Functions are objects too. What that means is that you can pass around normal types like ints and strings, but you can also pass a function to another function. So let's say I have foo, and then I have the doubler function. The doubler function accepts a function as its argument. So here I'm going to print doubler, and then I'm going to print the type of the doubler function, and then I'm going to call the doubler function with foo as its argument. Let's give that a try. So doubler is the function doubler. It is a class function type. And I can pass it the foo function, which gets multiplied, because I'm calling it inside, by 2. Now when you multiply the function You're actually multiplying the return value fizz twice, which is why you get fizz at the end. So, did you know that functions have attributes? Well, they do. Let's check it out. So here we just have def doubler. Let's find out what its attributes are. You can just run dir on it, and you can see that it has a bunch of interesting double underscore or magic methods associated with it. The magic methods in Python, like doc, double underscore doc or dunder doc and dunder name, are called magic methods or dunder methods. These methods are special, and they're usually used for creating everything in the object-oriented programming. So you can do a lot of cool things with the magic methods, and you can define them at the class level to make your own little magic functions or methods that can do lots of cool things with your objects. So let's talk about accessing a function's attributes. To do that, we can grab the doubler's doc, dunder doc, and dunder name. Let's see what that prints out. So dunder doc returns none, dunder name returns doubler. If the function doesn't have a doc string, then dunder doc returns none. Let's go ahead and fix that. So now we've added a doc string, doubles the number passed to it. Now when we print doubler.dunder doc, we can get access to the doc string of the function. Asking a function about itself inside the function. So now we're going to do something a little bit different. We're going to grab the object and just get its name inside of the function itself. So now when we call it, we can find out its name inside of itself, which seems kind of silly, but I'm just kind of showing you that you can do lots of things with a function that you might not really expect it to be able to do because a function is an object. So let's talk about adding new attributes to functions. Some people might call this monkey patching. So I have a function, my function.called equals true. So here I'm going to set .called to false, and then we can run this code and say that the function was never called because we never called it. So my function.called is set to false and nothing happens. Now let's call it and then see if it gets called. So now we know that it was called because when you call it, .called gets set to true. So we can kind of play around with this and use this to kind of track, when did this function get called, for example. Kind of a goofy way to do it, but it's kind of neat that you can do it this way too. And I've actually used similar programming steps for some debugging I've had to do in the past. Functions can be nested. So here I have the doubler function. Inside of it is a double function, and it doubles the x, which it returns, and then you return the double function, etc. So how does this work? Well, if you call doubler with nothing, you just get the double function back, and nothing really happens. But if you call doubler and pass it the number 2, it gets passed down to x, it gets doubled, and you get 4. And then here we're assigning doubler to d. So now d is the doubler function, and I can just say d4 and it'll double it to 8. This kind of gives you an idea of how decorators are going to work. And that's kind of what I'm building up to, is that we can grab a function and nest it, which is what you'll have to do when you create a decorator. Let's do a couple more things though. So x equals 10, y equals 20. We'll create a wrapper function, then we have a nested function. These two variables can be accessed inside of the function. X is shattering the x on the outside. So let's run this. The nested x is 5. The outside x is still 10. And y remains 20 throughout. Pretty neat. This brings us to closures. A closure is simply a function that is returned by another function. So here we return the multiplier. So a multiplier is the closure. Multiply by is a function generator or factory. So if we print this out, we can see that multiply by is just a function We can say multiply by 5 and say multiply by 5 and pass in the 5. What that gives us is a new function called multiply by 5. And so when we call it and pass it a value, we can start multiplying. That's kind of what we're doing here. We're creating different kinds of multipliers. So this one's multiply by 8. I'm not actually running it here, but I mean we could say and put this in here and run multiply by 8 and get 6 times 8 is 48. This kind of shows you how to create a function factory, but it also shows you what a closure is in this context. What do people use closures for? A lot of them use them as function generators or function factories. They're great for the adapter pattern in computer science that keeps a common interface. It can eliminate code duplication, which follows the dry concept, and dry concept meaning don't repeat yourself. And it can delay the execution of a function, which is nice. So here we have multiply by 5. It's not being executed right now. It's just being assigned to a variable. And then we'll call it later on in our code. That's what I mean by delays execution. Closures technically enable the creation of decorators. So again, a decorator will take a function that they are decorating and extend its behavior while not actually modifying what the function itself does. Decorators are normally applied to functions or methods, but they can also be applied to a class as well. Let's take a look. So here we have a timer function. It accepts a function as its main argument. Inside of that, we have a wrapper. Inside of the wrapper, we are going to time the result of calling whatever function is passed to it. So we'll call a function and execute it and put the result into a variable, end it, get the total time that it took for the function to run. We'll grab the function name, and then we'll print out how long it took to run in seconds. And then we'll return the result and the wrapper. Okay, so let's try it out. Here's def hello. We'll print out its name. We'll say hello equals timer hello, and then we'll print out its name again. So here we go. Prints out hello, so we got that right. Then we pass it to our timer code before, and hello is now named wrapper, which is kind of weird. The name changed. It should still be hello, but now it's wrapper. And then we can find out that it took a very little amount of time to run. So where did that name wrapper come from? If we go back over here, we can see that wrapper runs the function, and when that happens, it also replaces the name of that function. So now under name no longer refers to hello because it's been decorated by the timer function, and the inside nested function called wrapper takes over and completely replaces its name, which is a little bit annoying. We'll learn more about fixing that later though. For now, let's talk about decorator syntax. Starting in Python 2.4, which was released in 2004, almost 20 years ago, you can use the @ symbol to apply a decorator. So instead of writing it how we wrote it in that previous example, we can just say @timer. So now we can run it, and this time, because we added a time.sleep to our code, we can see that it took it 0.5 seconds to run. We could change this to 1.5 and rerun the code, and you can see that now it took 1.5 seconds to run. The hello.name is still wrong though. You can see it's still grabbing that wrapper name. Anyway, again, we'll get to that and how to fix it later. For now, let's talk about how real functions have arguments. So, normally a hello function would probably print out hello and then the name. So if we run this code, we're going to get an error because our wrapper function up here has no positional arguments. And so passing in the name confuses the decorator, and we don't end up getting what we want to get. So let's change it up. Now we can make the wrapper take in an infinite number of arguments and an infinite number of keyword arguments. By doing that, it can accept whatever arguments we want to pass in. So now when we run this, we get start of wrapper, end of wrapper, and no errors, and everything works the way we expect it to work. You may not have realized this, but you can actually apply multiple decorators to a single function or method. To do that, let's create a couple of functions. We'll create the bold function and the italic function, and you can just stack them on here onto the formatted text. So when we run this, bold is run first. Well, technically it goes from bottom up. So italic is run first and wraps Python rocks. And then bold is wrapped on top of the italics, and then it gets returned. So you end up with bold, italic, Python rocks. Pretty cool, pretty simple way to add multiple decorators to a single function. And you probably won't see a lot of this stacking going on, except in like web programming. I've seen that a lot in like Django and Flask apps. All right, so normally a decorator cannot be called directly. So if I do this and say I have my bold decorator again, if I do at bold open close parenthesis, we'll end up with an error. Bold is missing a required argument, func, because normally it is called implicitly and then it works. But when you have that open and close parentheses, it actually expects you to pass it in, and it just gets everything all messed up. So let's create a decorator that actually accepts arguments. I'm going to create a password decorator. It accepts an argument, and we're going to pass it. We're going to format this. Let's go ahead and change this to an F string. This code is a little bit old, and it doesn't really need to be written this way. So let's see. I'll change it like this. There we go. I think that'll work. And I've got a syntax error. Oops, I got my print statement messed up. Okay. So let's do that. And then inside of that, you can see we have a nested function, which is the actual decorator. It accepts the function that we're decorating. And then inside of that, we have our args and keyword arguments. So this is kind of weird, because here we have at the top level, the function gets passed in, and then the function's arguments and keyword arguments get passed in to the function that is inside the function that is inside the function. Anyway, let's see how this all ends up working. Trunc means truncating the password. I'd forgotten exactly what that meant, but I'm glad I put in these comments because that helps. Always put in comments if you don't know what's going on in your code. Okay, so I'm going to create a password decorator. It does something really silly and truncates your password to 8 characters. I've actually heard a funny story about a bank that didn't say that they did this, but I guess they truncated their password to like 10 characters or 8 characters or whatever, but didn't say that anywhere obvious. So when you go to type your password in, your code would get truncated, and only part of it would end up getting saved. Anyway, that's what this decorator does. It does something dumb and truncates your password to 8 characters. So the decorator argument is 8. The function accepts the long password. There are no keyword arguments. And then it returns the truncated password. Great. Decorators obfuscate some things, though. They obfuscate the name of the function as well as the docstring. Why does this even matter? So object pickling, if you play with the pickle module in Python, which can serialize your Python objects, it requires the name always be correct. It also matters in the testing frameworks. It can make debugging a real pain if you're trying to debug and the decorator changes the name of the test function that you're working on, and now you don't know which test failed. Also, Dunderdoc should be updated for introspection. So like PyCharm, VS Code, and Wing IDE, a lot of these things, they use introspection live while you're coding. And if you want to learn more about your code by, hovering over it or printing out the object with help, if it's grabbing the decorator's docstring, you're not going to get the useful information that you need about the function that you want to learn about. So here, let's talk about this again. Here's this example, def bold with our wrapper. We run this code, and you can see that formatted text no longer has a docstring, and it's no longer called formatted text. It's called wrapper. Neither thing is a good thing. There are ways to fix this yourself. So we could just say in our decorator function, we can do wrapper.doc equals function.doc, wrapper.dunderName equals function.dunderName, and this will fix it. Formatted text and formatted the passing text. We've just fixed the problem. But there's an easier way, because Python has a built-in way to do this. It's in the Func Tools module, and it's called wraps. So in our decorator function, we add another decorator that decorates the function that is passed in, and it will fix all the problems so that when we go to call it, the name is fixed and the dunder doc is fixed and everything is happy. Which way you choose to do this is up to you, but I almost always use functools.wraps to fix this problem. All right, moving on, let's talk about using a class as a decorator. This can be really helpful, and I find this to be a really good way to do decorators that take arguments. So anyway, we're going to create a decorator. We're going to call it myDecorator. It's a class. You just need to override the dunder call method and have it accept a function. And we're going to go ahead and be smart about this and wrap it with functools.wraps. And we'll just do everything else pretty much the same inside of the call function that you'd normally do, or the call method, that you normally do inside of a custom function decorator that you've written. So then let's try to call it. We'll just do myDecorator, and as this probably gives you an idea, this doesn't actually work. At least, not the way that I want it to work. I'm actually surprised I didn't throw an error. Maybe I meant to do this. Yeah. I think I messed that up. I think you need to have this on there for it to work correctly. All right. When using classes for decorators, you need to create an instance. So a couple of ways you could do that. You could do it the fake way I just showed you, where you add the parentheses on there at the end. Or you could say decorator equals myDecorator, and then just do add decorator. This also works. Doing these parentheses is a shortcut, and you shouldn't really do it that way. It's a quick and dirty way to do it, but you're going to create an instance every single time. And if you want to use this decorator in multiple places in your code, in your file, you probably want to go ahead and assign it, and then just call it once instead of creating new instances every time you decorate a method or a function. All right. So let's add arguments with the class decorator. So here I'm going to create my password truncator again. This time I'm going to create an init that takes in the truncation length. We'll just set it to truncation length, and then we'll go down here and do our call. And what this does is it allows us to pass in arbitrary arguments or keyword arguments to the password truncator decorator. And you'll note that to pass in arguments, you just have to override the init method. So now we can recreate our password truncator, and you can see what it's doing. In init, the decorator arguments are 8, then we're in our call method, and inside the wrapped method, which is inside the call method, right here. And everything works the way we would expect it to. One thing that I'm not showing is that it's also going to be printing out the correct password name. So let's go ahead and show that here. So you can see that because we're doing that wrapped part in here, functools.wraps, it's still going to keep the name correct and the docstring correct. Or the doc string. So this one doesn't have a docstring, but if we had a docstring, it'd be correct. All right. So now let's talk about actually decorating a class itself. So adding a decorator to a class without modifying behavior. So now we have an actual class. We'll go ahead and create the object, and we'll just run it to kind of show you, what's going on. Now let's create a decorator. In our decorator, we're going to add a class inside of the decorator. We're going to call it wrapper, and it's going to do some doubling, and then we'll return the wrapper class. Oops, let me go back. So I've run this one. Okay. Let's make sure I'm doing this right. Okay, decorator. So now we have @decorator added to our code. What this allows us to do is it allows us to add a doubler method to my actual class by using a decorator. So now my actual class can call doubler even though it's not defined in the class, which is kind of weird. It's kind of a weird hacky thing to do. Most of the time, what you'll actually do with your class is you'll subclass it. You won't use a decorator to add this. You'll just go ahead and subclass it. And so instead of doing, you'll do my actual class, and then you create a subclass, and it has the doubler in it. And then it works the exact same way. And that's probably the way you're probably used to doing it. But if you want to do it kind of in a sneaky way, you could do it with a Class Decorator. All right. An example of using a decorator on a class that is in Python is functool.totalOrdering. This was added. Some methods were added. Dunder less than, dunder less than or equals, and dunder equals were all added in 2.1. And then Python 3 uses these methods for comparison. The functools module provides the @totalOrdering to make it easier to write Python 2 classes that comply with the new Python 3 comparison requirements. And in Python 3, it just works just the same way. So it's a super handy way to use functools. I'm including this link to the Python Module of the Week series. It has a great tutorial on functools. Anyway, so if you look at this code, we import functools, we'll add inspect, and we'll print out some different things. And the cool thing here that we have is that we have functools.totalOrdering. So right now this object defines dunder indent, dunder equals, and dunder greater than. If we run pretty print and get the members, you can see that it has equals, greater than, equals, greater than init, less than, and less than or equals. And we didn't define all of those members ourselves. TotalOrdering added the ones that are missing. So that's a simple way to use a built-in decorator to add new methods to a class, which is kind of what I showed you how to do in the previous example by yourself. So you might be wondering, what other practical uses do I have for decorators? You can use them for all kinds of different things. Probably the most popular uses are to use decorators for authentication in Django and Flask, and for logging. I've also seen them used as a way to time code. So let's create a login decorator just to kind of see how that would look. So we'll create a log, accepts a function, we'll wrap it, we'll grab the function's name, we'll create a logger, set its logging level, tell it where to write its information, do all the other logging boilerplates, run the function, log the name and the result of the function, etc. This is good for auditing purposes. And then you can just add this decorator to any function or method you want, and now you have logs that you can run or get from anything that runs. A super easy way to add logging to things, and I've done this extensively in some code bases. Here's an example from Flask. Flask uses decorators to determine routing for the different web URLs. So in this case, we're routing the index page, the main page that you go to, will get routed to this hello world, which just returns a string. And so if you ran this in Flask, there would be a web page that would say hello world, and that's really all that it would say when you go to the main page. Here's some other common decorator use cases. Caching, retrying a function that might fail. Profiling, redirecting standard out and standard error. Like I said, logging is a really good one. But anyway, let's go ahead and look at a couple of Python's built-in decorators, like @property, @staticMethod, and @class method. I think I'll focus on @property for now, though. So in Python, you really don't need a setter or a getter because we aren't doing any kind of checking on X or age in this case. So here we have person with a self.age, but we're not doing any kind of checking. So we just don't care. We can set the object or the person object to whatever we want. So we can get the age, and We can print out the age and set the age just by using normal Pythonic assignments operators and accessing attribute access. But there are limits on an age. Most people don't live more than like 100 years. And if you want to start messing with stuff like that, you can use @property. And the reason I bring this up is that @property just makes it so that you can start like checking like a range. Like, everyone is born and they're greater than at 0 years of age. And most people don't get to be 115 or greater than 115. And so when you do that, you can now play around with the age, and it works great. But what if you want to use like an invalid number? You can make it raise an error. Now it says that it's an invalid age. You can't be 118, and you can't be -2. That's also an invalid age. And it shows you in the code that you're just doing things wrong. Whereas before that you set whatever age you wanted. You'd use properties for stuff like this, where for people who are wanting to enter their age. On many of those websites that used to check for your age. You might use this to set up bounds on, how exact you want to be in your calculations, or how fast your car can go. Stuff like that is where you'd use properties. Let's just talk a little bit about some of the other decorators in the standard library. So besides, @property and class methods and static methods, the context lib module has some different decorators. Functools has multiple decorators. There's a couple of other places that have decorators inside of it. If you want to see how our context managers work, a really simple way to do that is to just create a with, open a file, open creates a context manager when you combine it with the with statement, and then you can just write to that file. But if you wanted to create a context manager yourself out of your function, then you'd create a function, and inside that function you'd add a yield, and you just decorate it with at context manager, and then the rest of it all works. So this is a quick and dirty way to create a context manager out of your function. It requires you to import context manager from context lib, add a yield statement, and then have a finally statement later. In this case, we don't really need a finally because it'll run, but I'm trying to do good coding practices here. But I mean, you could get rid of the try except and just do f object equals open, yield, and then the finally at the end, and it would probably work the same way. Anyway, function overloading is a good example of decorators inside of Python's standard library. With single dispatchers comes from functools. You can just do multiple function overloading. I actually have another video on this topic where it lets you define different functions for different data types. So in this case, I'm registering integers for their A and B, and I'm registering strings, so that when you run it, add will run the integer version, and then it'll run the string version. And if you pass in something that isn't strings, like tuples and whatever, you'll end up getting an error because things don't match correctly, or you don't have the right kind of data types. Like you might have 1.2 and 3.4. It's not going to like that either. Because it's an unsupported type. So you're just going to get errors. I think I was supposed to get, unsupported type. Add a typo in there. Anyway, the other cool thing I want to talk about is caching. So functools has a caching way, has a built-in cache, LRU cache. I have another video on this too you can check out. But if you run this, you can just add caching to your whatever functions that need caching. So the first time it runs, you can get the max size of the cache set. We put in 3 to get the sign, and if you just rerun it multiple times, you'll see that then the value is cached. I have a much better video online that you can see how this is useful. Anyway, LRU cache information gives you hits, refers to the number of times you used a cached value. Misses refers to the number of times the cache was not used. And if the number of misses is high when the cache is not full, then caching this function is probably not a good idea. Anyway, that was a ton of information. I hope you found it helpful. In this tutorial, I hope to show you how functions work, introspecting functions, how functions are objects, a little bit of basics about what closures are, and how closures work with decorators. And then I showed a bunch of different decorator examples: stacking decorators, arguments with decorators, class decorators, decorating classes, practical decorators, and then just a handful of the decorators that are in the Python standard library. Anyway, there's a ton of information here. There's a ton of places you can go elsewhere to learn more about decorators. I have multiple articles on my website, Mouse vs. Python, that you can check out. And I have videos on func tools and context managers and lots of other things. So if you want to learn more about that stuff, check out my other videos on YouTube. Anyway, thank you so much for watching, and I hope you all tune in next time.